All right, Algebra 2, Chapter 4, Section 8. This lesson is about augmented matrices and systems. What are we going to learn today? We're going to learn to solve a system of equations using Cramer's rule. We're also going to learn to solve a system of equations using augmented matrices. So we got some new words we're going to learn: Cramer's rule, augmented matrix, and row operations. So let's get to work. You can solve a system of linear equations that have a unique solution by using the determinants in a pattern called Cramer's rule. Okay, I'm going to go through this and then we're going to see if we can make it make sense. We have a system: ax plus b y equals m, cx plus dy equals n. So we can use matrices of the coefficients and find the determinant of that one. And then we can replace the x coefficients with constants, and we can get the d sub x. So we can get the determinant of the coefficients. We can get the determinants with the x coefficients of the constants, and then we can get the d of y by replacing the y coefficients with the constants. And then we can find any solution using the d sub x over the base determinant is going to be our x value, and our y value is going to be the d sub x over d. This will work for any square matrix. So let's kind of just jump into it and see how this is going to work. So we're given an equation: 3x plus 2y equals 0, and x minus y equals negative 5. Okay, so let's set up our big matrix. What's our coefficient matrix? Our coefficient matrix is going to be 3, 2, 1, negative 1. Okay, what's our variable matrix? Just x, y. And what is our solution or our constant matrix? 0, negative 5. All right, so the d value is just going to be the determinant of the first matrix. So what is the determinant of the first matrix? That's going to be 3 times negative 1 minus 2 times 1. So that's going to be negative 3 minus 2, which would be negative 5. So our determinant of d is negative 5. Now, here's where it gets kind of neat. The d sub x. Okay, we're going to use the same matrix, but instead now we're going to use the constants matrix, and we're going to replace it with the x values. So we're going to get a new matrix that looks like this: 0, 5. All we did was replace the solution set with the x values to negative 1. So what's the determinant of that? That's going to be 0 minus 10, which would be negative 10. Okay, so now let's find the d sub y. So we're going to use the same equation, same principle, but now we're going to replace the solution matrix or the constant matrix with our y variables. So we're going to get 3, 1, 0, negative 5. Oop, and I say I made a mistake. This should be negative, so there you go. So cross multiply, so we're going to get negative 15 minus 0. So the d sub y equals negative 15. So let's go x. X equals d sub x over d. So d sub x was 10. Our d value is negative 5. So our x is going to be negative 2. Okay, let's go find our y value. Our y value is nothing more than d sub y over d. So it's going to be negative 15 over negative 5, which is 3. So our x value is negative 2, and our y value is 3. So we can go plug that back into the original equation. We can just double check. Let's just x minus y equals negative 5. So negative 2 minus 3 equals negative 5. So that's good. Okay. We can use Cramer's rule with 3 equations. Okay, it's a little bit more work, but we can definitely do it. So let's look. So I'm given 3 equations right here. So let's write our matrices up. So My first coefficient of x is 0. My coefficient of y is 1. My coefficient of z is 4. The second equation, looks like I got 1, 1, 1. The third equation, I have 2, negative 5, and 0. All right, there's our coefficient matrix. All right, here's our variable matrix, which is x, y, z. And then here's our constant or our solution matrix, 5, 8, 7. So it says find the x coordinate. So find the x coordinate. So the step one is find d. Well, d is just the determinant of the coefficients. So 0, 1, 2, 1, 1, negative 5, 4, 1, 0. Okay, and what was our first step when we find the determinant of a 3 by 3 matrix? Write the first two columns. Okay, and now it's just going to be products and sums. So 0, 0, 0, so 1 times, so 0 times 0 times 1 is 0. 1 times 2 is 2, plus 4 times 1 times negative 5 is negative 20. Okay, so that's going to be negative 18 minus something. So let's find the matrices, or the diagonals going the other way. 2 times 1 times 4 is 8. Plus 5 times 1 times 0 is 0, and 0 times 1 times 1 is 0. So it's going to be negative 18 minus 8. So that is going to be negative 26. So my d value is negative 26. Now I've got to find d sub x. So let's look. How do we do that? D sub x is going to be the exact same matrix, but instead of the x values, we're going to replace it with the solution matrix. So the solution matrix is 5, 8, 7, 1, 1, negative 5, 4, 1, 0. Okay, so let's zoom in a little bit. Step 1 to find the determinant of this matrix. Rewrite the first two columns. 5, 8, 7, 1, 1, negative 5. Okay, now we're just going to do the product of diagonals. So that's going to be 0. That's 7. And that's a really big number. Looks like negative 160. So it's going to be 0 plus 7 plus negative 160, which is going to be negative 153. Okay. All right, now subtract the matrices going the other way. So 7 times 1 times 4 is 28. Negative 5 times 1 times 5 is negative 25. 0 times 8 times 1 is 0. So that's going to be 3. So it's going to be negative 156 minus 3, which is going to be, negative 153 minus 3, which is going to be negative 156. So my x is my d sub x over d, which would be negative 156 over negative 26. So when you do the math, x is going to equal 6. So pretty easy stuff, just a little bit more work, but you could definitely solve all the variables. All right. Now you can also solve linear equations by using an augmented matrix. An augmented matrix contains the coefficient matrix and the constants, or the solutions, from the system of equations. Each row of the matrix represents an equation. So looking at this equation right here, negative 6x plus 2y equals 10, and 4x equals negative 20. Okay, you could set that up, your coefficient matrix and your constant matrix, so you could rewrite it as this: negative 6, 4, 2, 0. Your line does your separation. The vertical bar separates the coefficient and the constant, 10 and negative 20. So there's your augmented matrix. Okay. So an augmented matrix may contain, well, so an augmented matrix contains an entry of 0 for any term missing in the system. Okay, you can write them just like an equation from an augmented matrix. So write the system of equation for the augmented matrix 6, 0, 3, 1, 1, negative 5. So it's going to be 6x equals 3, x plus y equals negative 5. Everybody see how we do that? There's no y in the first one, so it's just, we just left it blank. Okay, easy enough. Now we can use, with augmented matrices, we can use our row operations. To solve any system of equations using augmented matrices, you can use one or more of the following row operations. You can switch rows, you can multiply a row by a constant, you can add a row to another row, you can combine one or more of these steps. So there's a lot of stuff you can do to manipulate these matrices. Using augmented matrices, let's just look through what the book did. Using augmented matrices to solve this equation. Okay, so there's my base equation. So we wrote it in an augmented matrix. Okay. So the first one would be just a 1 and a 2. There's my x and y. My solution for that one of my constants, negative 1. My coefficients on the second equation are 2 and 5. My solution's 4. All right, now it says I can manipulate the data any way I want to eliminate variables. So I'm going to multiply this top matrix by 2. All right, so I'm going to get negative 2, negative 4, positive 2. Okay, my bottom matrix stays the same at 2, 5, negative 4. So I can add these together now, and I'm going to get 1 and negative 2. I'm going to get 0, 1, negative 2. So basically we find out y equals negative 2. Okay, so now I can replace the second line. So go to my first equation, 0, 1, negative 2, my line. I'm going to replace it. I can plug this one in, 0, 1, negative 2. I can multiply this one by negative 2 as well and get this, 1, 2, negative 1, 0, negative 2, 4. And I can add those together, and I'm going to get 1, 0, 3. So I get x equals 3. Okay, we'll do a little bit more work on these in class to make sure you get it. But just understand, you can manipulate augmented matrices by those row operations we talked about earlier. Please review the video if you have questions, but that concludes Algebra 2, Chapter 4, Section 8.